logistic regression model. Actually, we use this model for the classification of the objects. For example, suppose there is a group of people and we want to classify the white people and brown people. So we must have been given some features of white people and brown people, and based on those features we actually train a model which can tell us about a particular person, whether it is a white person or a brown person. So what is the use of sigmoid function here? Sigmoid function is actually, if you follow its mathematical function, it's y equals to 1 upon 1 plus e to the power minus x. What it does, whatever input you will give to this function, input means the entry x here, so what will happen, it will map that input between 0 and 1, and the flow of this function is something like this. It goes to 0 with negative infinity and it goes to 1 with positive infinity, and it cuts the x equals to 0 at y equals to 0.5. So what we do, we actually, like I explained the example of classification of people. So if we provide the feature in this function 1 upon 1 plus e to the power minus x, x is actually the feature, so it will evaluate some value of y and it will be mapped between 0 and 1. So this 0.5 is actually taken as a threshold value. So suppose this x is, for example, it is a melanin available in the skin texture of any particular person. If it is greater than 0.5, then that person is black. If it is less than 0.5, then that person is white. So this is the use of in decision making of this sigmoid function when we classify certain objects. So it's something like, if we are using the features and we are evaluating the value of y, and if the value of y is coming out to be more than 0.5, so it falls in this category, and if it is, that is what you have written in your notes as a class 1, and if this value is below 0.5, so it will fall in the class 0. So whatever is the class 1, class 0, it depends on the problem. So let's try to understand how actually it works. So suppose if I take the same example of classification of brown people or white people, and here we have to be very clear whether we are going to use the linear regression or the non-linear regression. Linear regression means we are going to fit our data with the function ax plus b. So what we are going to do, we are going to fit this value z into the sigmoid function, which is y equals to 1 upon 1 plus e to the power minus z. So we can put it here 1 upon 1 plus e to the power minus ax plus b. So this x, for example, for the understanding point of view, if we are classifying the people which are either white or black or say brown, so if x is the feature of the person which we have taken as an input data, which is the melanin and which has some data value, say c, and it is available for the lots of people for which data is given to us. Now what we'll do, we will fit this value of x in this sigmoid function, so definitely it will give the value between 0 and 1, and depending on that we can actually classify whether that person is a white person or a black person. For example, if its value is coming out to be 0.75, so it means there is a 75% chance that that person falls to a particular category. So but this x is actually one of the feature. We may have more than one feature, and in that case it is going to be look like ax1 plus bx2 plus c. So again this value z will be put here and it will fit accordingly. So what will happen when you call the this logistic regression model in the Python library? What it does, it fits the data and it trains the model and evaluates the optimal values of a and b, for which it fits the best possible fitting of the data with this particular mapping. So what will happen, suppose you trained your data and you passed all the values of x in this function and you got an optimal value for a and b, and when the moment you got an optimal value of a and b, then you will get a line y equals to ax plus b. So if you are very clear how this linear regression works, so let me revisit. Suppose you have a data like this and we want to fit it by a linear regression. So what we needed a straight line which actually fits this scattering of data with the least amount of error. So in the same fashion, the moment you will get the value of a and b, you will get a straight line for the data of the people which we have taken as a white people or the brown people. So we can understand like this. Suppose they are the white people and say they are the brown people. So when you will fit your data in this sigmoid function and after training you will get an optimal value of a and b, you will get this straight line y equals to ax plus b, and then you can draw this straight line like this. So what it does, it provides that if your data falls after this line, then data are going to be a particular class, that is what you can call like class 1, and if the data falls in this class, then you can say the particular person is belong to class 0, in our example white people or brown people. But this regression need not to be a linear regression. Instead of this y equals to z equals to ax plus b, we can take a non-linear function. So in that case we can have a non-linear boundary as well, which is not going to be a linear line. Hope it clears your doubt.